Good afternoon. Today we are going to see the problems on projectile motion, that is from 2019 and 2022 question papers. So now to see more videos on engineering mechanics or especially civil engineering, you can see here you have different playlist. Now for mechanics, you have to go to engineering mechanics, and here you can have 22. So this is 23rd video which relates with your engineering mechanics. So I have shown here some videos over here, and now we will go with problems on this. So this is last part related with your unit 5, which is motion of projectile. Now we have first problem, that is a ball is thrown by a player from 5 meters above ground level, clears the 25-meter high wall placed 100 meters ahead of the player. If the angle of projection of the ball is 60 degrees, determine the velocity of projection of the ball. So problem is simple, but students are going to commit the mistake. Now it is given. So we have ground 5 meters below. So this is ground. And we have wall over here 25 meters. I always prefer to draw the diagram, and from this you will get everything clear. Now we have ball over here which is at 5 meters. So I have this distance as 5 meters. 25 meter high wall placed 100 meters ahead. So I have this distance 100 meters. And 25-meter wall, so we have this distance 25 meters. If the angle of projection of the ball is 60 degrees, now velocity angle. So let this velocity is V, making angle 60 degrees with horizontal. Determine the velocity of projection. Now I already told you, you have to go with two axis. First with x-axis, another we have y-axis. And in y-axis, I already told you, you have to use motion under gravity. Now we have x is 100 meters. And ux we have v cos 60. Now in y direction, now try to understand, this is initial position. We have this, just clear. This is final position. Now how we will get x? Vertical line from initial, vertical line from final, and then we have 100 meters. Now to get y, horizontal line from initial, horizontal line from vertical, and this is my value y plus 20 meters because final is above initial. Students are going to consider y20 and they are going to lose the marks related with this. So we have y is equal to 20 meters. We have uy is equal to v sine 60. Now we will solve this. So we have x equal to ux into t. Now x we have 100. Ux we have v cos 60 into t. And from this we will get, therefore, we have v is equal to 100 upon cos 60 into t. And 100 upon cos 60, so we have v is equal to 200 upon t because cos 60 is 1 by 2. Now we have here y is equal to uyt minus half gt square. Now we have y is 20 meters equal to uy v sine 60 into t minus 9.81 upon 2 into t square. Now we have this we have 200 upon t. So we will put it 20 is equal to 200 upon t sine 60 into t minus 9.81 t square upon 2. So this tt gets cancelled, and if we will solve this, then I got this value, that is 200 sine 60. So we have 200 sine 60. This will come on left side minus 20. So minus 153. So minus 153.21, and that is equal to minus 9.81 t square upon 2. And from this we will get value of t, that is equal to 5.59 seconds. So I have t is equal to 5.59 seconds, and therefore v is equal to 200 upon t is equal to 200 upon 5.59. And from this we will get value of v is equal to 200 divided by 5.59, and that is 35.78 meters per second. So we have velocity of projection, and that velocity we have 35.78. This is velocity of projection. Velocity of projection is 35.78 meters per second. Then we will go with another problem. A golfer hits the ball from A with initial velocity 50 meter per second at an angle 25 degree. Determine the horizontal distance AB. We have to go this distance AB. So I will mention it as X. And maximum height. So I will say this will be Y, maximum height. So again, we have to go with the same fashion. I already mentioned you. I will take it in on next page. So we have given data. So here we have diagram. So we have X, and then we have Y. So data related with X, you can see we have AB. So X, that is equal to AB equal to, we have to write this, Ux I will write, which is equal to 50 cos 25. This is x-axis. And x, I am going to say this distance as x. And then we have x equal to AB equal to Ux into T. So Ux into T. And we have AB equal to, or x equal to 50 cos 25 into T. Now we have Vy, which is equal to 50 sine 25. And then we have to find value of maximum height. So we have, this will be Y. So where we have Y max? So Y max at Vy equal to 0. And therefore we will get, this is Uy and this is Vy0. So what is formula? So we have formula, that is Vy square, that is equal to, so we have Vy square equal to Uy square minus 2Gy. Now Vy we have 0, Uy we have 50 sine 25 whole square minus 2 into 9.81 into y max, I will say now. And from this we will get y max or maximum height, and that we will get 50 sine 25 square divided by 2 into 9.81. We have 22.76 meters. So we will get this value of y, that is, I didn't get this, just a minute. So I have as this value 22.76 meters. So 22.76 meters. Now we are interested to find AB. Now we know what is y when it will reach B. So in first case, we have this is initial position and we have this is final position. And then we have solved this y. Now what is our initial and final? So it will start from this point and it will again come to the ground. So now this is final position, this is initial position. And then we have this is distance AB. Now this is 50, so and this is 25. Now we have y equal to 0. And then we will use y equal to uyt minus half gt square. And then we have 0 equal to 50 sine 25 into t minus half into 9.81 t square. And from this we will get 9.81 t square by 2 equal to 50 sine 25 into t. This tt gets cancelled and we will get t is equal to 50 sine 25 into 2 divided by 9.81. And we have this value 4.31 seconds. And now once we know time of flight from initial to final is 4.31, then we have to put here t is equal to 4.31, and therefore AB is equal to 50 cos 25 into 4.31. And we will have AB, that is 50 cos 25 into 4.31 equal to 195.31 meters. So 195.31 meters. So now question you can see maximum height and horizontal distance. So horizontal distance is AB equal to 195.31 meters and maximum height equal to 22.76 meters. And then we have last problem. A projectile fired from the edge of a 150-meter high cliff. So now we will draw the diagram. So we have 150-meter high. So I will just draw it. So we have this ground and we have this is 150-meter high. And then 180 meter per second. We have 180 meter per second and making an angle of 30 degrees. With the horizontal, the greatest elevation above the ground level. So we have to go above the ground level maximum height. Now this is initial position and maximum height. We have this will be final position. This is initial and this is final position. Now we will write y direction. So we have uy is equal to 180 sine 30. Now we have to find out value of y, where we have Vy equal to 0, because at maximum height Vy is 0. And we have to use this and we will solve this problem. So we have equation motion under gravity Vy square equal to Uy square minus 2Gy. And this y distance we will get, this will be my y. Now maximum height means we have to find y max. We have to write from ground. So we have to add 150 in this. So from this we will get 0 equal to 180 sine 30. So we have this 180 sine 30 is 90 meter per second. So I will directly use 90 square minus 2 into 9.81 into y, and from this I will get y is equal to 90 square divided by 2 into 9.81, 412.84 meters. So we have y is equal to 412.84 meter. Question is greatest elevation above ground level. So greatest elevation above ground level and how much. So now y max, if I will mention whichever I have shown in figure, so y plus 150, and y we have 412.84 plus 150, and then we have this is equal to 562.84. So 562.84 meter. So we can write here 562.84 meter. Now what is next? Horizontal distance from the ground to the point where the projectile strikes the ground. Now try to understand second part. So we are in this fashion. And now we have, this will be again initial position. This is 180 meter per second. Angle we have 30 degrees. Now this is initial position. Now it will go up and then it will strike the ground. So now I have, this is final position. Now what is y? So we have, this will be y. Now my final position is below initial position. So I have, this is 150 meter cliff, and therefore I have y is equal to minus 150 meter. Now we know we have Vy, which is 180, Uy I will check, Uy 180 sine 30, which is 90 meter per second. And then we can use y is equal to Uyt minus half gt square. Now, y we have minus 150, then we have, this is 90t minus 9.81 by 2 into t square. And we will rearrange the terms. We have 9.81 t square by 2 minus 90t minus 150, which is equal to 0. And solving this, we will get value of t that is equal to 19.89 seconds. And now we have second horizontal distance between these. So we have, this will be from the point of gun. And therefore we have, in x direction, we have ux equal to 180 cos 30. And now t we have 19.89 seconds. And therefore we have x equal to ux into t, and that is 180 cos 30 into 19.89, and then we will have 180 cos 30 into 19.89, 3100.54 meters. And question, you can see horizontal distance from the gun point. So distance between gun point and projectile at ground is 3100.54 meters. So likewise, you have to make clearly into two parts, that is along X and along Y. Subscribe Civil Engineers Technical Hub channel to see more videos. Thank you.